Greetings, math fans. All right, so this is day two of Sequences in Series Part 2. And basically, yesterday we looked at problems like n cubed, things with n cubed, or actually you start out n squared, n cubed, n to the fourth. Right? We looked at explicit formulas, doing it by hand, and using your graphing calculator. Well, today I just want to talk a little bit about when do you look for that versus when do you look for something geometric or arithmetic. So the general rule here is before looking at complex sequences, first look at simple sequences. Because kids always do that. I teach this like the more complicated way, and then all of a sudden they start like look. That's the first thing they look for. It's like, no, look for the easy stuff. Okay, so let's look at some simple ones. The first one could be an arithmetic, and you would actually identify arithmetic right away anyway, because you would, when you start doing your common difference, you would see there's a difference right away. So you would see that you would get a D. So this is basically, if it's arithmetic, it's going to be linear. So you could use linear regression on your calculator, but I think it's a waste of time because this is like really easy, right? You're just going to use your a sub n equals a sub 1 plus d times n minus 1. Really, really easy. You're also going to look for geometric. That means you divide, right? And so we're going to be looking for r. So just remember to divide. To see if there's an R value. And the third kind is maybe it's arithmetic over arithmetic. Okay, so arithmetic over arithmetic could be, like a sub n on top equals, 2n plus 3. A sub n on the bottom is 5n minus 6. And that could be your general equation, 2n plus 3 over 5n minus 6. So sometimes you want to look at the top, and sometimes you want to look at the bottom separately. But you don't do that until you check that and that. Because sometimes kids, they don't look for geometric, and they go right to looking at the top and the bottom separately, where really what you do is you divide and figure out, oh, it's just geometric. It's really, really an easy problem. Okay? So you definitely want to check some different things out here. You could also have something where it's geometric over arithmetic. It might be going up by, 2 times 2 times 2 times 2 times 2 on top, and the bottom is going plus 3 plus 3 plus 3 plus 3, so it could be geometric over arithmetic. So you have to kind of investigate that. It'll never be geometric over geometric. Okay, never, never, never. Let me show you why. So let me clear this out of here. If I give you guys 2/5, 6/10, 18/20, so this is unreduced already, and 54/40. This is what kids do. They look at the top and they go, oh, the top is being multiplied by 3. So that means a sub n equals a sub 1 times r to the n minus 1. That's the top. And then the bottom is a sub n is equal to 5. It's going up by times 2. So times 2 to the n minus 1. And that's what they give me as an answer. A sub n equals 2 times 3 to the n minus 1 over 5 times 2 to the n minus 1. Okay, now that is correct, but it's not simplified. In fact, you would get this wrong because that is truly, this is a true geometric. And you're like, well, what do you mean by that, Mr. Kerfus? Well, if I took 6/10 and I divided it by 2/5, you would get 3/2. And then if I did 18/20 and divide that by 6/10, I would get 3/2. So really this problem is r is equal to 3/2. So my actual answer for this problem is a sub n equals a sub 1, which was, go back to the top here, 2/5 times r to the n minus 1. That is actually my solution. Okay, so you look like you had geometric over geometric, but if it's geometric over geometric, that means you can write it as one geometric general term. Okay, so just kind of be careful about that. So this is your going to be your solution. All right. Let me give you another example here. If I gave you 3/5, 4/15, 13 over 31, 36 over 53, and 79 over 81. First of all, just to save a little bit of time, it is not geometric. If I divide it out, it doesn't give me any common value of r. So what I'm going to do now is I'm going to test out the top and the bottom separately. Well, I kind of looked 5, 15, 31, 53. I don't really see anything. Top 3, 4, 13, 36. Don't really see anything. So you want to start to investigate it. So let's look at the top here. And if I do 3, 4, 13, 26, and 79, and let's look at the differences. This is what we did yesterday. So the difference between this is 1 and this is 9, 23, and 43. Okay, and then below that is 8, 14, and 20. And then this is 6 and 6. So it's 1, 2, 3. This is going to be n cubed. We'll get to our calculator in a little bit, but it is a cubic. Okay, the bottom is, let's look at 5, 15, 31, 53, and 81. So if I look at these differences, it's 10, 16, 22, and 28, and then the difference between here is 6, 6, and 6. So it went twice down, so it's n squared, or quadratic. Okay? So now what I need to do is put those separately, not as a one fraction. You need to put them separately. It can't handle a different top and a bottom. Okay? But I'm going to put the top in my graphing calculator. So let's actually do that. So let's go back to Stat, Edit, and let's go up here and hit Clear, Enter. Cursor over and hit Clear, Enter. So we're going to put in first. They have 5 terms, right? So we're going to do 1, 2, 3, 4, 5, and then cursor over, and then I'll put 3, 4, 13, 36, and 79. And then I know that the top one, we figured that was a cubic, so let's do that. We're going to hit Stat, Calculate, Cubic, 6, Enter. Okay, so remember that 1.7 e negative 11? That's like saying 0. So really, this is ax cubed, so it's 1x cubed, or x cubed minus 2x squared. So x cubed minus 2x squared. Oh, and then plus 4 on the bottom. Okay, so let me just move this down here. If I can move it down, there we go. Okay, so the top is going to be, like I said, n cubed minus 2n squared plus 4. Okay, let's put the bottom one in now. Okay, let's clear this out of here. We'll hit Stat, Edit, and I can leave the 1, 2, 3, or 5 there for L1, and for the bottom it's just going to be 5, 15, 31, 53, and 81. Okay, and then we're going to hit Stat. We know this is a quadratic because we figured out before, so we're going to do Stat, Calculate, go to quadratic, which is 5, hit Enter, and those gave us nice numbers. So it's 3x squared plus x, or plus 3x squared plus x plus 1. So let me shrink this down here again. So I'm going to write in terms of n. Okay, but it's 3n squared plus n plus 1. So my complete general term then for the top and the bottom, I'm going to write it as a sub n is equal to n cubed minus 2n squared plus 4 over 3n squared plus n plus 1. Woo! That was a humdinger. Okay? So that is my general term. No splitting required. So kind of remember too, sometimes math fans, I mean, they can get even a little more complicated than this because, again, we could have arithmetic over geometric. A lot of different things that we can have. But you can use your graphing calculator to figure out some of the more complicated ones. Sometimes you might have to unreduce. So just remember that. You might have to unreduce fractions. Okay? And, because if you have something where it's, like 2, on top it's 2, 4, and then let's say it's 2, 4, 6, and instead of 8 it was 4, and then 10. Let's say that was the top, my numerator. Well, I know that the pattern is 2, 4, 6. Well, that needs to be an 8. So if that was like 4/3, I would have to multiply this by 2 over 2 to get it to be 8 over 6. And now it's 2, 4, 6, 8, 10, and the numbers work out nicely. So sometimes you have to multiply by, to unreduce the fraction. Like I said, in this case it was 4/3, and I multiplied it by 2 over 2. Because multiplying by 2 over 2 doesn't change it, right? It just makes it 8 over 6 to give me an appropriate sequence for the top. Okay? So that's kind of the scoop. It's a pretty quick lesson on day 2. Basically, the homework is more of last night's stuff plus a mixture. It's got everything else in it. It's got geometric, it's got arithmetic, it's got ones with the top and the bottom different, and it's just got a lot of stuff to it. Okay? So all I can tell you is always look for arithmetic and geometric first, because those are the easiest, and then move on to to the more complicated type sequences. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.